Okay, let us start it now. Let me go ahead and share my screen. Okay, I hope that everyone is able to see. If any one of you not able to see the screen, please ping me on chat, and then I can see actually if there is any issue. Okay, so myself is Ranjit Karni, and I have around 13 plus years of experience in IT industry, and majorly I have worked on DevOps and Azure Cloud and AWS. So I am from Vpoc Innovations, and this is a company where actually we are extensively working on DevOps and Azure activities. Today in this topic, actually, I'll be giving a demo on Azure DevOps, like actually why this DevOps has been come into picture, and then what is meant by this Azure, and then how come there is a combination of cloud and the DevOps, and what will be the future actually if we are going to learn this thing. Actually, what is the future that we are going to have? So let's go ahead and dig into this thing as a part of demo. So the history and how it has been started. So before actually DevOps has been, we have been hearing a buzzword like DevOps since the past 6 to 8 years. Before that, there were different teams who were coordinating with the developers, and then who were getting to done the work, like whether it could be a build and release management team, whether it could be a networking team, whether it could be application packaging teams, or whether it could be a software configuration management team, or whether it could be a version control system team, release management team, and a build engineering team. So change coordinator. So different teams were available, and there was a very difficult of coordination, and each team was having different responsibilities, and ultimately whenever there is an issue, it was really difficult to find out who was really working, whose issue is it really. And that is how actually the history. Let's look into this one. Actually, before the evolution of DevOps, really there was no connection between the operations team and the development team. If suppose there is some kind of environment that has to be get created, like let's assume I have to create a dev environment, it used to take good amount of time, because operations teams has to understand the requirements. They have to place the request, get it, do the things manually, and then when the developers are deploying their code into that one, later they are identifying that it is not working. So whether the issue is from the development side, or whether the issue is from the operation side, no one knows. So there was not a proper connection between the developers and operations team, due to which actually the delivery used to affect a lot. So and due to which actually the time delay was happening, and even the budget side, it used to be more, and the developers were responsible just for building their applications, and the operations team was responsible just for implementing their solutions. There was no formal way of communication between the developers and the operations team. So this is the problem that has been created, and there is a major hurdle that used to be there between the developers and operations team, and it used to lend to actually lot of tend to actually a lot of problems, a lot of issues, due to which actually no one knows actually whether it is from operations team or from the development team. So around 2007, there was a movement that has been started in the Europe, where people thought, okay, why can't we remove these hurdles? Why can't you remove these obstacles between the developers and the operations team, and they can coordinate each other very well, and then they can work from the beginning of the project till the end very coordinated way. So that is how actually they thought, like, let's have a direct connection between the developers and operations team, just not as a position or something like that, but it has to be as an environment. The DevOps should be as a culture. That is how actually they have started up developers plus operations, which has become a DevOps. So that is how actually they have thought about the DevOps thing in the year 2007, somewhere in the Europe. And from there, people started creating a culture of DevOps instead of just thinking a DevOps is a person or a DevOps is a resource actually, or it is a specific position. They're not thinking it like that actually. Now people are thinking that DevOps is a culture which should be incorporated in a project to get the results very quickly. So now we understand like actually okay, DevOps is a thing which has to be a combination of developers plus operations, right? So do we require to so is it developers required to become a DevOps engineer, or then operations is required to become a DevOps engineer? Okay, let's see now. Okay, what are the prerequisites to become a DevOps engineer? There is no formal career track for becoming a DevOps engineer, whether you are from a development background or whether you are from a operations background or you are from a freshers background or you are from database background, anything actually, it doesn't matter. As long as you are enthusiastic, as long as you would like to learn and have a holistic view of DevOps culture, the beauty is DevOps accepts everyone from different technologies, because of all technologies related works in the DevOps, whether it could be in development, whether it could be in operations, whether it could be release management, sprint coordination, whatever it may be. So all the things have been coupled and formed as one culture, which is called as a DevOps culture. So if you are from development background and if you would like to learn the DevOps thing, then already you know the coding part. So the only thing which you require to learn is the networking part, which we will be teaching. In the similar way, if you are from the operations background and as you already know, the networking background, the only thing is that actually you should be jumping into a couple of scripting languages and then start learning those scripting languages based on in order to do the automations on the DevOps. So either way, whether it is developers or whether it is an operations with their specific level of expertise in the existing background, they can brush up their skill set and then learn little bit of new things with respect to DevOps automation part, and then they can become a DevOps engineer. The only thing is that you should be having enthusiasm to learn the new technology, and if you would like to see the holistic view of the entire DevOps technical environment, then yeah, this is a perfect track for you. Okay, so I was talking like there was an obstacle between the development and the operations team or the business team or the customer. So for each and every section, actually, there used to be a good hurdles or obstacles in the earlier days, due to which actually the delay was affecting a lot. So let's see actually what was the obstacles that I was talking about, so that you will understand better how we have removed those obstacles down the line. Okay, so if you see concept to class, the flow, it is now actually earlier. So who has to get the project for a company? So it's basically a business team or the persons actually who are having some ideas in their mind, and then they thought like, okay, if I am implementing this idea, then what would be the return of my investment, and what kind of solution for my idea I can build it. So if the business team is the person actually who will be having such kind of thoughts, and once they get that idea, they will be contacting this development team and stating like, hey, this is what my requirement, and I want the this type of solution that has to be done. Okay, so can you guys go ahead and give that solution to me? So and accordingly, developers will be writing some kind of requirement analysis, they will be doing the architecture designs, they will be doing the development, they will be doing different types of testings, and they will be creating the packaging part. Whereas the operations team, in order to perform the deployment on any one of the environments, they will be hardware provisioning, and then they will be installing the configurations of the OS, they will be installing the application servers, um, they will be configuring the traffic managers, they will be once the build is packaged by the development operations team will be performing the deployments, and ultimately they will be setting up some kind of monitoring and logging for both application at the service server level. So once everything has been deployed, ultimately who has to take those fruits, it is by customers. So customers will be the persons actually who will be enjoying the benefits of the product that has been developed by all these business or development or operations team, and they are the persons who will be enjoying the outcome. But if you see, between the business development operations and customers, there is a thick line, that is a black line that is there actually. Why it is there? Why? Because earlier they were following the waterfall methodology. Let's take an example from business and development. They used to follow the waterfall methodology. So once they give the requirement by the business team, they were not coordinating with the development team and then looking into the product until the completion of the solution by the development team. Once the solution is completed after 6 months or 8 months, let's assume, or 1 year, when the business team is looking at the product, they are thinking that, hey, this is not what I have asked. So I have asked a different solution and you have come up with a different solution. So ultimately what is happening, whatever the 1 year effort that has been kept by both business and the development team is completely wasted. So the budget that whatever they have allocated for the development of this thing has been completely wasted, right? So this is one of the example which I am saying between the business team and the development team. So first let's go ahead and see at the development level what kind of automation, what kind of improvement, what kind of things that we can improve, so that there will be a continuous feedback that can be established within a development build itself. So just let us talk about the development thing. So if you see, I am performing a development, okay, I am performing a testing, and then I am creating a build. So while I am performing a development each and every day, why can't I go ahead and implement a continuous integration? So continuous integration here, it means as soon as the developer has committed his code into, because a project can consist of, let's assume, 100 members, 100 developers. So each and every developer will be writing his own style of code basically. So at that point of time, when the 99th person or 100th person is committing the code whatever he has written, when he is putting the code into the main code where remaining 99 persons also have written, maybe his code is affecting the remaining 99% code, or remaining any one of the 99% code might be not allowing this 100th person code functionality. So there will be some kind of dependency between the coding and all those things, right? So module to module and all those. So when this person is merging his code, pushing his code into the main environment, main line, so at that point of time, it's better that we can check, instead of waiting till the release, it's better that we can check as soon as he has pushed that code into the main code. It's better that we can check whether the entire 100 people code is now collectively working fine or not, whether we are able to compile it properly or not, whether we are able to see whatever the code that has been written by these 100 people, whether the quality of the code is proper or not, like whether they have written too much of duplications code, whether they have taken too much of code from the internet and just copied over there, whether they have any kind of code smells, and also we can see whether they have any kind of technical depth which they have to look into those things. Such kind of things we can run. Along with that one, we can also run the unit test cases. If the developers has automated the unit test cases, definitely as a part of continuous integration, we can compile the code, we can run the static code analysis, and then you can perform the unit test coverage as well. So if this can be a continuous process for each and every commit, what we can ensure is that, okay, every time whenever a developer is committing his code, the compilation is happening, so that we can understand that there won't be any kind of compilation issues in future, because the code is compiled as soon as the code is committed. If there is any issue in the code, then immediately we can send an email notification to the concerned developer stating like, hey, whatever the code that you have committed into the remaining people's code, due to your code actually the compilation is getting failed, please have a look into that one. So by that time, so with this one, what is happening, you are getting a continuous feedback, you are giving a continuous feedback to the developer as soon as he has written some set of code, right? In a similar way, that after the development there it is written like testing, regression, or performance. These are the different types of testings, right? Regression testing or a performance testing or user acceptance testing. There will be different testings that will be performed before moving to the production. There will be different types of testings like integration testing, smoke testing, functional testing, manual regression testing, or automation regression testing, performance testing, user acceptance testing, or monkey testing. Whatever it may be, different testings actually will be performed on different scenarios and different environments. So all these things, why should we be doing manually? Can't we do this automated way, so that as soon as the code is compiled, as soon as the static and unit test coverages are done, we will be doing the deployment on the dev environment, and let us run any one of the regression suite or something like that continuously on every day night, so that the next day morning when the developers are coming, they will not only come to know about the compilation issues, and they will not only come to know about the quality of the code, they will also come to know that whatever the code that they have written, does it have any kind of bugs. So if there are any bugs, before the testers rising the bugs, they can immediately fix those bugs, and then they can commit the code into the main branch, so that what is happening, the immediate feedback, the quicker feedback is happening before the testing starts from the testers, as soon as they have committed the code into the version control system. So continuous integration and continuous automation, if these two things can be implemented, then that will be really good. In addition to that, let's see. Yes. Okay. You see, continuous integration, let's implement, and the continuous automation. If you are having these two things, then you can establish a continuous development life cycle. But if you see, still there are the hurdles. Still, we did not remove any kind of hurdles. The black lines, the thick black lines between any one of the different teams. Okay, so now you have, let's concentrate first about the business and the development, because they are the initial guys actually who will be working in the project, right? So business guys are the persons actually who are having the ideas. So ultimately they are the persons who are becoming the product owners. So if if the business person is giving an idea to the development team, and if he is not coordinating with the development team on each and every day, or on a continuous basis with the development team, if the development team has any kind of questions with respect to the requirement, you know uh, they have to ask the business team continuously. So why can't the business team continuously coordinate with the development team and join a kind of calls like scrum calls, or everyday call for 10 to 15 minutes, and trying to understand whether any one of the developers is having any kind of issues or need any kind of clarification on the requirement. And in the similar way, once the developer has completed his development, if business team, instead of waiting till the end of the project and looking at the code, or sorry, looking at the output, why can't he be looking at the result on a regular basis? Like we can say, like for every 2 weeks, let's see actually what has been developed, at least whether this is proper or not. And then after 2 weeks again, whether the entire 2 weeks plus 2 weeks changes have been proper or not. So that what is happening, instead of waiting till the end of the time after 1 year and then understanding like this is not the product that what he require, if he can see it on a regular basis, like for every 2 weeks or something, if there is anything that has been getting deviated from the requirement that what he is expecting, immediately he can give a quicker feedback to the development, so that instead of 1 year time wasting, hardly it will be 1 week or 2 weeks of time that will be getting wasted, right? In addition to that one, anyhow, he will be having a coordination with the development team continuously on each and every day to clarify the requirements and all those things, so that there will be a minimal chances that actually the product will be going and I would say like point percent actually, either one or two features or something like that may be deviated or something. But more or less, whatever the product that is expected by the business team, the same product will be delivered ultimately outside. So from business team, if someone can become a product owner, who should be having an end-to-end idea about the requirement, and who should be knowing actually what exactly the business is expecting. So someone from the business team, if he can act as a product owner and reviewing the code reviewing the output, and then clarifying the requirements. If someone is there always, then development team and business team can collaboratively work together, and then they can achieve the product that whatever is expected. So some kind of agile methodology has to be implemented instead of going ahead with the waterfall methodology, so that we can reduce the business and the development team efforts. Yeah. And then product versioning in the sense, for every 2 weeks when you are releasing the product to the product owner to see actually whether it is what as per the requirements, whether they have developed it or not. If product owner is assuming like, okay, this is not this is what I am expecting, okay, till now whatever you guys have written, this is the perfect thing, so let us create a version for this one. Like before releasing, let us make it as a 0.001 or 0.1, 0.2, something like that. Maybe from 0th version itself, let's start it, and then let's try to do a product versioning for that one, so that we, for every good releases that we are doing internally for those things, we can have one version, so that if anything, the next version is getting failed, and if it is not working, the previous version for the 2 weeks back, whatever you have released, that version will be still there with you, so hardly 2 weeks of efforts will be lost. So that there will be a continuous feedback that can be established between the business team and the development team by implementing all these best practices. And you are able to see, you can see that the black line has been removed now with the processes, different types of processes, and the automations implementation between the business and the development team, and you can see that the continuous feedback has been established. Okay, so business team and the development team has been collaboratively working together, and they are able to get the continuous feedback. But still on the right hand side, operations team and the customers team and the development team, between these three things, actually still you have a hurdle, right? So let's think that actually from the operations point of view now. So in the operations background, in the operations thing, you have hardware provisioning, OS configuration, application servers, network and cluster traffic management, application deployment, server monitoring, application monitoring. So you have different tasks that are supposed to be performed in the operations background. So how can you improve this process? Okay, so now let's assume that you have to create 100 missions for the developers. You know, at that point of time, all the developers require what, a kind of mission with a kind of operating system and a specific type of softwares that are supposed to be get installed, and specific type of configurations that are supposed to be required. So how come a operations guy can perform by going on each and every mission, setting up the operating system, and then installing the software, and then setting up some kind of configurations that are required by the developers? Because we are human beings, definitely we may commit some other mistake in any one of the missions. So that what is happening, as we will be committing, even though we were trying to do 100% success rate by installing each and everything and configuring each and everything in each and every mission, but then as we are human beings, maybe some other mission we may be not able to do what we are expecting to do, like actually some kind of configurations might have been missed, let's assume. So what is happening here, even though you are testing one mission, you have to test all the missions, all the 100 missions, because it's a manual intervention and manual process completely. So in any one of the missions there could be an issue, so again tester has to test all the 100 missions. So why can't we do this hardware provisioning? Why can't we do this operating system configuration or patches installations? Why can't we set up these application servers? So all these things, why can't we automate auto provisioning, and then auto infrastructure creations and everything, you know? Along with that one, server monitoring and application monitoring, why do we require to have one resource simply sitting over in front of the systems and then understanding, okay, what is happening, okay, why the servers size is increasing, why the RAM is fully utilized, and then it's going out of things, things actually. And why application is not responding properly, why the response of the application is very slow, such kind of things actually. If the if is it really required to have one resource who is sitting in front of the monitoring monitor and then monitoring continuously? Maybe we can automate these kind of things as well, like application server monitoring, application monitoring, and the server monitoring. There are a lot of tools that we can use, and then we should be able to automate those things. So like this actually, if we can automate all these things actually, we should be able to improve the operations team tasks, and we can get the continuous feedback as well. So ops modernization can be performed with the help of auto provisioning, auto configuration, predictive analysis, auto deployments, and virtualization and service management. So that end-to-end visualization. So if business team wants to see, okay, whether all the 100 missions have been catered or not, just one click, anyone, whether the development team can do it, or business team can do it, or the operations guy can do it. And as it has been automated, there is no requirement for any one of the guys to inform to other members. There will be an email notification which we can configure, so that as soon as the 100 missions have been set up, automatic email notification will be sent to the development team, business team, and the operations team. And there is no requirement for the manual intervention, and people will, everyone will be on the same page. So let's see, still there is a hurdle between development, operations, and customers, right? So let's see actually, why can't we remove the obstacles between the main line between the operations team and the customers team? Now operations team has performed the auto deployment. Now ultimately the deployment is completed. Who are the end users who are going to enjoy? It's customers. Customers are the person actually, customers are the people actually who is going to enjoy this output files actually, output actually. So when they are looking at the outcome, and if they have any kind of issues with those things, there should be some kind of place actually where the coordination has to be happening between the operations team and the customers team. Because as soon as we sell the product, definitely out of 100 customers, maybe one or two customers, let's assume that they are having some kind of issues with their systems where they are not able to install it, or if it is a web application, they are not able to install it due to some cookies issues or something like that. They are not able to open my application in a proper way. So there should be some kind of way that they customers can coordinate with the operations team and raise an issue, or get a clarification, or get a solution resolution from the operations team. So the communication, the feedback analysis has to be, the feedback part has to be a established between the operations and the customers team, so that they can make a phone call to them and then explain them like, hey guys, this is what I am facing actually, can you please resolve it? So that the operations team guys can coordinate with those guys, and then with the customers, and then they should be able to resolve it. So by with that one actually, we should be able to remove the obstacle between the customers and the operations. So when you are coordinating continuously with the customers by implementing all these best practices like auto provisioning, virtualization, auto configuration, auto deployment, auto auto usage monitoring, auto log monitoring, feedback analysis, service management, all these things when you are implementing, you will be able to get the continuous feedback, and which is called as lean ops. So now you have a continuous feedback between the business team and the development team, you have a continuous feedback between the operations team and the customers team. But still, if you see, there is a line between the development and the operations team. Now you have mostly automated everything and established the process already. On the development and the business side, you have implemented the agile methodology, you have a product owner, you have a CI/CD pipeline, you have a continuous automation, you have established all the things with the Kanban dashboards and all those things, and you are able to get the continuous feedback. Whereas in the operations and customer side, you have established a lean ops where auto provisioning, auto configuration, predictive analysis, virtualization, auto deployment, auto monitoring, auto logging, feedback analysis, everything has been implemented, and you are able to get the continuous feedback. But between the development and operations, you have to remove this hurdle, as you have automated most of the things already. just by establishing some kind of best practices, uh, um, rule set, we should be able to remove the obstacle between development and the operations team. So like something like ITIL process, which you will be able to implement, and the DevOps thing has been come into picture, and from business level till the customer level, you can establish a continuous feedback. Okay,
Sorry to
this is
interrupt.
how actually. Yeah, please go ahead.
So, what kind of obstacles will it be happening from the business to the deployment?
Just
Can
now
you
I
please?
said, right? So let's take an example. Like I have a maybe once the demo is completed, can I uh, take the questions if you don't mind? Because let me finish the stuff, and then maybe we can have 10 to 15 minutes of questions time. Okay,
Sure,
is
sure.
it okay? Yeah, thank you.
And
Okay, see here. Uh, so you implement all those things, provide a dashboard where everyone can see, provide an alerts if something is going wrong, or provide an information radiators or the quality metrics, all these kind of things by creating, actually the audit logs, the server logs, and all those things, and different using of different tools on different tasks. You will be able to achieve this continuous feedback. Okay, now DevOps main objectives. What are the things that we will be doing? So we will be whatever the automations that whatever I am talking about, all those things will be normally performed by the DevOps team, like installation of the servers, hardware, OS, configuration of the servers, network storage, monitoring of the servers, CI/CD pipeline, responding to the outages, IT security, change control management, release management, backup and disaster recovery planning, managing the active directories, asset tracking, everything actually. From the beginning of the project till the end of the project, DevOps guys are the persons actually who will be involved into the um, in the project actually. So what is meant by infrastructure as a code? So now we understood, okay, DevOps is something that actually where the combination of developers plus operations with the set of automation things that whatever we have done we can do, and setting up a culture in a project in an environment where the specific ITIL processes and all those things can be established. Now in the operations side, I was talking about auto provisioning and all those things. What does that mean actually? So whatever the softwares, let's assume developer has asked, hey guys, I want a dev environment within half an hour of time with with a Kubernetes cluster. Okay, having 100 missions inside a cluster. Okay, uh, first of all, you require to, if it is doing manually, then 100 missions if you have to configure means how much of time it will take for you to do those things. Okay, so that's the reason I said, like, okay, instead of taking that much of time, if we can write one time code which can be executed parallelly on 100 missions, and as you can test it in one mission, if it is working fine, as the same code has been reused in 100 missions, you can 100% say that, okay, I have tested and there is no manual intervention, everything is an automated way, everything has been a mission thing. So if what working, then obviously the remaining 100 missions can be working and everything will be in sync, right? So for doing such kind of activity, there will be some methodology which you should be doing actually, which is called as infrastructure as a code. So whatever the infrastructure that you are creating, whatever the system setups that you are doing, whatever the initial setup that you are doing, like setting up the missions, and then installation of the operating systems, configuration of the things, and then installing the application server, all these kind of things, the initial setup, the infrastructure that whatever you are providing to the developers, or whatever the infrastructure that you are creating as a part of environments. Okay, each and every environment in a project. So all such kind of things you can automate using infrastructure as a code. What is meant by infrastructure as a code? It's nothing but actually using a different tools, like in the market, the Chef, Puppet, Ansible, Terraform, and if it is cloud specific, cloud formation template, you have ARM templates, you have Azure PowerShell, you have. So you have different tools of different scripting languages that you have based on the specific tool set. You should be able to automate the workflow, the code, the CI/CD pipeline, you will be able to write the program so that the program can be executed and it will automatically create the infrastructure for you. So that is what it is mentioned in the slide. If you see, with the arrival of tools like Puppet, Chef, the concept of infrastructure as code was born. With the infrastructure as a code or programmable infrastructure means writing code which can be done using a high level language or any descriptive language to manage the configurations and to automate the provisioning of infrastructure in addition to the deployments. It's not about the deployments, it's about the automation of configuration and automation of provisioning. With the things you can go ahead and implement with the tools, you can go ahead and write some code and then implement those things, which is nothing but called as infrastructure as a code. Now, whatever we are talking, we are just talking about the DevOps. So where is the cloud? Is there is that mean cloud is nothing but a DevOps is nothing but a cloud? No, there is no relation between the, it's not something that actually cloud is same as what is meant by a DevOps. So let's assume I don't want to have a cloud. Okay, I have my own missions in my company, in my office. I have a physical missions that are available in my office itself, which I can see. Okay, um, those missions also has to have some kind of infrastructure like OS installations and all those things. There also you can provide a DevOps concepts. There also you can write infrastructure as a service, sorry, infrastructure as a code. Infrastructure as a code, basically, so that you should be able to spin up the instances pretty quickly actually. So it's not some, and you're on the on-premise instance. On-premise is nothing but the place where you are able to see actually in the same location of your office actually. Okay, so you can perform the deployments onto the servers, just not manually, through automated way using DevOps concepts. Should be able to do that one. So everything actually, whatever you are doing, you should be able to do it on the on-premise instances. But now the cloud concept has been come into picture, where let's assume I have procured a server, okay, with a specific configuration. It's not something that down the line for n number of years I'll be having the same set of configuration, right? Because the technology is growing very fast actually. Today it could be with core i5 pentium or something like that, and then later point of time the different faster CPU may come in the market, and more GB of RAM will come into market, you know. At that point of time, whatever the old servers that you have, whatever the investment that you have done, that will be wasted actually, because that is a old one which will be slower and all those things. And the second thing is that you have to maintain a specific office where actually all your systems has to be maintained, like AC has to be there, plugs should be there should be a plug networking concepts which should be there, and then there should be a dedicated resources 24/7. There should be a dedicated resource to monitor if there is any issue in the systems and all those things. So there is all these kind of things has to be maintained by yourself only. Instead of that one, why if we are using a cloud, you know, actually some provider will be providing the systems to you which you can connect through remotely in his on-premise area. In his office itself he will keep the provider, and he will allow you to connect to his missions through online, you know, um, and then you can use those missions by yourself. So whatever the things that you are using, just for till that point of time, you should be able to make the payments. So cloud is nothing but actually it's at the remote, just accessing the things over the internet is called as a cloud computing. Cloud is nothing but an internet, and cloud computing is nothing but accessing, whether it is a remote mission or whether it is a storage, whatever it may be, that is hosted over the internet. When you are accessing those things through the internet, that is nothing but called as a cloud computing. So if it is a cloud, but then there also you need to have a remote mission, even though you're connecting through internet. And in the remote mission you need to have an application server to be installed. In the remote mission you should be having a patches, OS patches should be installed. In the remote mission you should be performing an auto deployment. In the remote mission actually you should be able to do some kind of automations with respect to the developer activities, that whatever they are requesting. So the same DevOps concepts, that whatever we have implemented on the on-premise environment, the same concepts still we are implementing on the cloud. So as people have been most of nowadays, actually instead of using their own servers in their on-premise locations, as they are using the cloud, and as they are utilizing the DevOps concepts to automate the things even over the cloud, that is how people now started calling it as like they have combined both the words, and then they are calling it as now cloud and DevOps. So if a person is having a knowledge on DevOps, if a person is also having a knowledge on the cloud, then it's really good, because people are mostly looking for the combination of these two things. It's not something just okay, I know what is meant by a puppet, I know what is meant by a chef, or I know what is meant by a VSTS, I know what is meant by an version control system like Git. That doesn't be enough. There could be a couple of chances that you may get it, but people are nowadays looking at a broader level, where actually if a person is having the entire DevOps plus cloud knowledge, it is much more value added for the company, and then they can utilize this resource either on the cloud infrastructure, or they can implement utilize him as a part of automation with respect to the DevOps activities on the cloud or on the on-premise. So that's the reason. What is the relationship between the cloud computing and the DevOps in a sense? It's not something that cloud means DevOps means cloud. Obviously, they are different words, but ultimately, cloud DevOps will be used even on the cloud to do the automation activities. So they are independent, but there is a good relationship between the DevOps and the cloud. Okay. So what is the difference between automation setup and the what is the difference between the automation setup and the manual setup of infrastructure? Let's assume you are doing a manual setup of your infrastructure, the system creations and all those things. Manually setting up servers with operating systems is one thing, whereas automated way, the example, the same 100 missions, with one click you should be able to set up 100 missions immediately. And when you are doing manually, if you are installing one thing in one first mission, the same installation you have to go and click the buttons in each and every missions till the 100th mission. All the things to be repeatable by user only, whereas in the automated way, once you write a code, the same code you can be executing with one click in all the 100 missions parallelly, so that what is happening, you are reducing the time, right? Not easily testable. Why? Because that's what I said, manually when you are doing any one of the mission unexpectedly as a part of human errors, normally that whatever we create human prone errors, we may create some kind of issue. So the tester has to test in each and every mission till the 100th mission, right? So whereas in the automation way, if you are going ahead, if you have tested one mission, that itself is enough, because the same mission, the same code is getting executed in all the remaining 100 missions, right? So once you test, give me a minute guys, sorry about that. Yeah, sorry, actually I was running out of battery. Yeah. Okay, so next point is scalability constraints, time consuming and manual testing needed for each node. I said the same thing. Whereas in the automation way, if you have tested one mission, that itself is enough, and the remaining missions can be shoved up automatically. And if you are doing it manually, you never know whether one mission that you have configured is exactly the same as the other mission, maybe some kind of configuration, maybe some kind of folder creation or something like that, just a small thing which I'm talking about, maybe we might have missed out, right? So you cannot say like each and every environment 100% equal same as dev is equals to qa is equals to prod, you cannot say. Whereas in the automation way, as you have tested the one environment, the remaining environment, as you have used the same code to execute it on all the for all the servers, you can 100% say that dev is equals to qa is equals to prod. So that is how actually it's better thing that if you are going ahead with the automation way, you have to you can easily ensure that all the environments are in sync. Okay. Now, what is cloud computing, which I have already said? Cloud computing is nothing but a process of using a network of remote servers hosted on the internet to manage and process the data rather than on the local servers or personal computers. So somewhere it will be hosted and you will be accessing those things through the internet. So now the cloud services has been divided into three types. One is infrastructure as a service, and platform as a service, and software as a service. Infrastructure as a service is nothing but what is the benefit when we are going to the cloud? One thing is that you no need to bother about the uh, procurement of the servers. Immediately whenever you want, you can just go ahead and take that one, and you no need to have your people to monitor the servers. You no need to have a space for keeping your systems. Okay, you no need to bother about the network plugs and all those things, ethernet and all those things has to be getting connected and all those things. But still, you can utilize those hardware and everything. But on top of that one, if you want to have any mission, you can just go ahead and spin up an instance like a virtual mission and install your operating system, and then install your application server, install deploy your application, uh, and you deploy your data and then start using that one. So infrastructure as a service, in the sense, they will be providing a hardware for you, on top of which you should be setting up your own virtual machine, you should be setting up your own application server and all those things as a part of infrastructure as a service. Whereas platform as a service, in the sense, you even not even required to know about the virtual machine creation. You not require even to know about the application server and all those things. Just you develop your application, we will provide the instance to you, and just copy your code into the instance and then start testing that one. So what is happening, you can spend more amount of time on the development, and once the development is completed, just go ahead and deploy the code onto the server will be ready for you, which will be maintained by the providers like Azure or AWS or someone. Whereas infrastructure as a service, you have to write your code. Along with that one, you have to create an instance on the cloud, you have to create a virtual machine on the cloud. Whereas in the PaaS service, you don't need to worry about the server also will be created by them. You just develop your application. That is what your job as a developer. You develop your application and then just go ahead and deploy onto the server, which will be provided by the providers. Whereas software as a service, in a sense, even you are not required to write the code. The code also will be written by them, the deployment will be done by them. You just use it as a end user. If suppose gmail is something that which you doesn't require to write a code, you are using it as an end user, right? So whatever the things that you are using it as an end user, like emails or the any games that you are using, all these things, actually you'll be using as SaaS is nothing but software as a service. So these are the different tools or the components or the tasks that we will be doing as a part of DevOps thing. These are the different components, like you need to know about the version control system, where in the source control you will be implementing the unit test cases, the hooks, the auditing, the build and deployment, alerts, custom scripts you will be writing, some kind of test cases you will be executing as a part of continuous integration, and as a part of continuous inspection you will be implementing using some kind of different kind of tool sets, and there will be different types of tech stacks that you will be using, and you will be performing a continuous deployment, continuous testing, continuous monitoring. So all these things actually I will be going in depth actually when we are talking about the concepts like what is the difference between continuous integration, continuous delivery, continuous deployment, when we should go for continuous delivery, when we should go for continuous deployment. All these kind of internal related concepts we will be discussing um, uh, uh, in our training. So these are the different types of tools that we may be required as a part of DevOps. On the high level overview, if you see what are the different types of operating systems we will normally use, like Linux, Windows, and Mac OS. And infrastructure as a service means you will be using the cloud like Amazon Web Services, Azure, Cloud Foundry, OpenStack, Rackspace, Google Cloud. And the virtual machines creations part, actually you will be using VirtualBox, VM creation. On the configuration management to create infrastructure as a core part, actually you'll be using Chef, Puppet, SaltStack, um, Ansible. On the databases deployment part, actually you'll be using MySQL, PostgreSQL, MongoDB, Redis, Oracle, MSSQL. And for the compilation part, you'll be using Ant, Gradle, Maven, Ant, Maven, NUnit, Gulp. Okay, all these kind of things we'll be using. And the application servers, Tomcat, WebLogic, Nginx. Okay, as a web server, that is. And as a static code analysis, it is going to be a Sonar Cube and Sonar Runner. Security side, you will be using Veracode, Black Duck, Fortify. And messaging queues, it will be a Memcache or RabbitMQ. And there are a lot of tools. DevOps has a lot of tools that are available in the market. We, based on the project to project, actually we will be using different set of tool set. Okay, so what is the DevOps Pro? Basically, you will be compiling the code. You will be compiling the code is nothing but building the code, and then you will be running a continuous integration and then continuously testing and giving the feedback continuously to the developers. If everything is fine, they will merge it to the main branch. From main branch, you will deploy to QA environment, perform different types of testings over there, like integration testing, functional testing, performance testing, user acceptance testing, and everything will be done. And then if everything is fine and if the business team is giving an approval, then ultimately it goes to the production. So this entire flow we will be discussing in depth about each and every level actually here during the training. So this is on the high level. This is what the DevOps flow. So ultimately we have been discussing about the DevOps. We have been discussing about the cloud, and so ultimately it is which is called as a cloud and DevOps. So there are, as I said, there are a lot of tools that are available in the market, but nowadays actually Azure DevOps is something. Azure is a cloud. DevOps is nothing but um, there are a set of tools that are provided by the Microsoft to perform the DevOps activities like build and release management and all those things, which earlier called as a VSTS, now it is called as an Azure DevOps. Okay, so there are a lot of tools that are available in the market, but Microsoft has a specific set of tools that has been given by the Microsoft. Like Azure, they have it by themselves. Version control system, that is VSTS Git, they have provided it. And for the build and release management, they have provided the Azure DevOps. Azure DevOps consists of version control system, it consists of build and release management, it consists of bug tracking methodology, it consists of project management. All the things has been combined together, and then they have formed it as one tool called as an Azure DevOps. In addition to that one, we will be talking about Azure Cloud, in depth about the Azure Cloud as well. So these are the topics that we'll be discussing. About the version control system, VSTS, the CI/CD pipeline, the release management, dashboard, reports and planning, and Azure services and microservices deployments. Like we will be talking about the Docker, we will be talking about the Kubernetes, and we'll be also talking about any one of the scripting languages like PowerShell. And we will be talking about as a part of infrastructure as a code. We will be talking about ARM templates, which is will be part of an Azure ARM templates. Okay, so these are the topics which we will be discussing about. I think now I am done with the demo. It's already 9. Do you have any questions? We can discuss for 10 minutes. Someone was asking a question actually. Now you can go ahead, please.
Yeah, actually, I'm a developer. I don't have much idea on this. So I just want to know what generally the DevOps guy do in terms of the activities, and what will be the roles, and what will be the technologies regularly used on
Okay.
that.
Okay, got it. So you are a developer, right? Ultimately, once you write the code, there should be some environment that should be available for you to test your code as a part of unit testing. Similarly, the code has to be promoted to the QA environment where the testers has to have some place where they have to test the code. Okay. Similarly, production server is there where some place where we have to deploy. So who has to create all these things? DevOps are the guys who has to create all those things. That is one step. Okay. The second step, actually, once the things have been automated and once the environment has been created, there should be someone who should be coordinating and then with the developers and everyone and ensure that a proper release management process has to be established. Okay, such kind of things will be done by the DevOps guys. And there should be some kind of security things that has to be executed on each and every day. The regression suite has to be executed on each and every day, and there should be some kind of release documents that has to be published to the client, like what kind of stories has to be deployed and all those things. So these kind of things will be done by the DevOps people. If it is a microservices or something, then the creation of the containers, creation of the clustering, monitoring of those things, setting up the logging of those things, all these things will be done by the DevOps persons only. So from the
Okay.
beginning of the project itself, they will be starting involving in these activities.
So they create like build definitions or like that. Is that the correct?
Exactly. They create the build definitions, and then they are the persons who are completely whole and sole responsible for all those things.
Okay. So how will be the career growth if you take the DevOps? Like, suppose I
See,
have.
I have around 13 years of experience in the same field actually. I would say like this is one of the top technology where I have seen the recession periods. Out of my experience, I have seen a lot of recession periods like 2008 that time, and then even recently actually there is a good recession period that was running right actually. So at that point of time, I saw a lot of technology. I don't want to name them, but I saw a lot of technology where actually there was a problem. But even right now also DevOps stands somewhere in the first or second place in the market, where it will always, since 2005 or 2006 I have been seeing that actually. Even till now, I always see that DevOps is playing a prominent role in the market always.
Suppose I am a senior software engineer. Okay.
Mhm,
So how
mhm.
will be my growth like after lead? Uh, After
So
lead.
DevOps, that's what I said, right? DevOps is the person actually, see, ultimately whomever you may be, okay, ultimately you need to have a system, right?
Mhm.
Ultimately, if you once you write the code, it has to be go to the production. Okay,
Mhm.
whatever may be that, this process has to be done. Okay, so DevOps thing is the thing always which will be there. Okay, and not only the DevOps don't think with respect to the tool set. It's a kind of culture actually which you should be understanding. Like you have to implement the processes, you have to come up with the best practices. So these kind of things, whether you are a lead or whether you are a manager, I'm at the management level, but then still I will be involving in the technical activities and all those things. So uh, it depends on you actually. So as long as you are in the technology side, whether you are whatever may be the experience, whether it is 10 years or 15 years or 20 years, trust me,
Mhm.
so you will be still having a lot of future. I have seen people who are still more than 25 years of experience and still they write the code, and still they perform the DevOps activities. Why? Because they are still in the technology side.
Okay. So best practices in the sense, can you illustrate with one example? I'm not able to connect actually. Yeah. Can you
Okay,
please tell
best
me?
practices. Okay, let me take you one simple example. Branching strategies. Do you hear branching? Because you are a developer, you should be knowing.
Yeah, yeah, I know.
Okay, let's assume you are a developer. You have to get your code to be reviewed by your lead. Okay, without
Mhm.
getting the code reviewed by your lead, you are committing your code into the main branch.
Okay.
We don't know that whether your code is properly compiling or not. We don't know whether your code has any kind of code quality or not. We don't know whether you have written the unit test cases or not. Even though you have written the unit test cases, whether they are executing successfully or not, right? All these kind of things has to be done before committing the code into the main branch. So if you are raising a pull request, then your lead has to review it. We have to run all these things, and then that thing has to be merged into the main branch. Simple thing. Instead of all these best practices, if you are going ahead and merging the things directly without knowing to anyone, if you are merging the things into the main branch, that doesn't work out, right? Because due to your small 2 or 3 lines of code, if the compilation is getting failed, 99%, remaining 99% has to wait till it is getting fixed. You know, such kind of time, you see, you have to calculate when 100 people are waiting for a small bug. In the sense, it's not just about the budget, also you should think about the time, also you should think remaining 99%, if they are waiting, in the sense, it's a huge impact for the business, right? So that's the reason, actually, this is one of the small example which I have given to you. Like there are a lot of implementations we should be doing, lot of automations we should be doing, and then wherever there is a scope for the best practices to be implemented, the process to be implemented as a part of ITIL processes, we should be able to implement all those things.
So for example, we will be merging and doing the these things, right? Pushing and
Okay, let's
so
give a
what?
chance to others. Let's give a chance to others also. So is there any other questions? If not, we can
Yeah,
ask. Anyone has any
question.
question?
Yeah, I
Yeah,
have
go
a
ahead.
question. So what are you going to teach doing in Azure DevOps? Like what are the SQLs do you teach? Is it like test plan, pipelines, codes, repos,
Exactly,
artifacts?
exactly. Everything,
And is it
everything.
like
I'll be
you going to tell the yeah?
okay.
So I have a question. Uh, this is Chanakya.
Chanakya.
Yeah. I don't know your name.
My name is Ranjit,
Okay.
and yeah, go ahead,
Oh,
please.
yeah. Sorry, Ranjit. So I'm already I know some little bit about AWS and little bit about what is DevOps and all. So,
Hmm.
but I have joined a job in and they are pushing me into Azure. So, and also they are using Bamboo tool, and they are like kind of doing data migration and refactoring and
Hmm.
CI/CD pipelines,
Using
this
what?
kind of stuff
CI/CD pipelines using Bamboo? What?
using Bamboo or something.
Oh, okay. Hmm.
So, what can I expect? Like, would
Okay.
these course
Good
can help
question.
me, or how it is
Yeah.
like?
So in
And
the in
also,
the, mhm, go ahead, please.
I have heard like VSTS and everything somewhat. So
Mhm.
VSTS will be helpful for me, and I
So
I need to
VSTS
know.
is nowadays, now it is called as Azure DevOps. So don't get confused. VSTS name has been changed now. Okay.
భయపడితే భయపడినట్టు ఉంటుంది ఎవరికైనా.
Hello.
Someone is speaking. Actually, can you please go on mute? Yeah,
Yeah.
please go ahead. Okay.
Yeah. Tell me. Sorry.
Uh, so Chaitanya, actually,
Chanakya.
VSTS is sorry, yeah, Chanakya. Sorry about that. Chanakya, actually, VSTS is now called it as Azure DevOps. Okay. Which is a part of continuous integration, right? So I will be covering VSTS part as well. So if you see my syllabus, actually, initially I will be talking about what is meant by cloud computing, where I'll be talking about the benefits of cloud computing, the features of cloud computing, and then what is meant by an infrastructure as a service, platform as a service, software as a service. And once you are done with all these trainings, actually, what type of job that you can get, what are the different types of roles that you are able to fit in, and then what is meant by a public cloud and a private cloud, what are the principles of parallel and distributed computing, what different types of virtualization concepts, and what are all the different types of clouds, public cloud or a private cloud, that are there in the market. And once the introduction about the cloud computing is completed, then we will be entering into the Azure part. In the Azure, initially I will be talking about the overview of Azure and how the platform looks like, and then how you can access the Azure, how can you create an account in Azure, what is meant by an ARM, Azure Resource Management, and how to use the portal, the GUI, how to you can use it, and then how can you manage that Azure using an Azure portal or using an Azure PowerShell, and what are all the different types of services. On the high level, I will be discussing about those things for a one or two sessions, and then I will be entering into the main concepts from here onwards. That is the virtual networking. In the virtual networking, I will be talking about what is meant by an Azure virtual network, how to create a virtual network, how to create a subnet, how to create a network security group, how to create a virtual machine with IaaS, how to add the security rules in the network security group, what is meant by a DNS servers, what is meant by a route table, what are the different types of connectivities that you can make with the virtual networks. If suppose you want to set up a your Azure virtual network with your on-premise instances, or from your Azure to AWS, if you would like to connect, how can you do that one using a point-to-set
So
connectivity?
would you be covering the firewalls also in this?
Everything,
About
everything. I'm talking. Yes, let me complete it.
okay.
Point-to-site connectivity, site-to-site connectivity, multi-site connectivity, express routing, VNet to VNet connection, VNet peering, traffic manager, network watcher, application gateway, application load balancer, the firewalls, everything I'll be covering as a part of virtual network. And then I'll be moving to the virtual mission. In the virtual mission, I'll be talking about what is meant by a virtual mission, what is meant by update domain and fault domain, what is meant by as availability set and an availability zone, what is the difference between a managed disk and a traditional disk, that is unmanaged disk, and then how to create a virtual mission and installing an IAS, how to create the same virtual mission through PowerShell, how to create the same virtual mission through ARM template, how to create the same virtual mission through a GUI. Okay, different ways. And how can you take a backup, how can you take an image, can you take a snapshot from an image, how can you create a virtual mission, what are the different types of data types that are disk types that are available, what is meant by an operational management suite that you can implement, and how can you do an encryption of the disk. Once this is done, then I will be entering into the VSTS, which is now called as an Azure DevOps. Like how can you create an Azure VSTS account? What are the roles and responsibilities that you can set up in VSTS? How can you create a project? How can you create an organization? Inside that one, actually, how can you perform, write the deployment group creations, and then how can you create a Kanban dashboards? How can you create a Scrum management? And then in the Azure DevOps itself, in the VSTS itself, actually you have a repository management, that is a version control system. So how can you create a repository? How can you create a master branch? How can you, what is meant by branching and merging? How can you create those branches? How can you delete the branches? Everything through a command prompt, actually. And then how can you raise a pull request? How can you accept a pull request? And then what is meant by a submodule? What is meant by a cherry pick? All these kind of things I'll be talking in the version control system. And then we'll be moving to the CI/CD pipeline, where I'll be talking like how to create a build definition, how to set a build setup, how to do this environment setup, and then how to set up a load balancing, how can you set up a cluster creations. All these kind of things I will be explaining as a part of continuous integration, how to do a build and release management activities. Okay, and once that is done, then I will be moving to Azure storage. In the Azure storage, I will be talking about different types of storages like blob storage, file storage, table storage, and queue storage. These are the different types of things that are available. And in the blob storage, again, we have different things like page blob, blog blob, append blob. So we'll be talking about all those things as well. Okay, then we will be entering into the app services, where we will be talking about this is about the PaaS service, which is available, where we'll be talking about web apps. How can you create a web app, and then how to uh, in a web app in the web app, actually, how can you deploy the application, how to set up a deployment slots, how to access these things, how to monitoring these web apps, how can you set up the alerts and everything. Those kind of things we can be we'll be discussing over there. And then we'll be discussing about Azure SQL database, like how can you do the migration between on-premise to the Azure SQL, and how can you create a database in Azure, how can you maintain that Azure database, and then how can you import and export the data in the Azure. So all these kind of things we'll be discussing in the Azure SQL database. Next, how can you take the backups, how can you do the replications, what is meant by asynchronous and asynchronous replications, and then what are all the best practices that you can be implementing as a part of recovery and backup systems, and then how can you set up a disaster recovery environment. So we'll be talking about Active Directories and these things are completed. Then we'll be talking about microservices, about the Docker. How can you create a Docker container, and then what is meant by a Docker file, what are the different types of commands that are available in the Docker, how can you create a very small Docker file, and then where can you deploy that one. You can be you can deploy that one in you can deploy that one in a Kubernetes cluster. Means okay, what is meant by a Kubernetes cluster? How can you set up a AKS Azure Kubernetes service? Actually, in Azure Kubernetes service, as a part of VSTS CI/CD pipeline build definitions, how can you write a build definition to create an image and deploy that image as a container in the Kubernetes cluster? So these are the things actually which we'll be showing, and finally we'll be talking about some best practices, and if there are any tools in the available in the market. Uh, that and if there is any kind of things that you can do, different types of certifications that we'll be talking about. Okay, these are the things I'll be talking mainly.
So what kind of web applications means like there are different types of like
See,
web.
I will not be talking about the coding. Okay,
No, no,
I'll be
no, no. I'm asking like you'll be using web applications, right? Is it like .NET itself, or what is it? What kind of web applications?
okay.
Java
You are
based.
talking about the technologies. Okay, deployment side, actually I'll be showing you both, like both .NET deployments and as well as the Java deployments. Okay, we'll be talking about the deployments. We'll not be talking about the technology means development and all those
No, no,
things.
no, no, no. I'm not asking about development. I'm just asking what kind of web applications you will be using, and that's all.
Huh? Sorry, web applications. So sorry, web application in the sense you are talking about
What kind of
IAS.
like no? As you said earlier, like I got the idea. Like you will be showing the .NET applications as well, and Java applications deployment as well. Yeah, I got that. And
Okay,
how about data migration and all? You will not be covering, right, in this?
data migration, database you are talking.
Yeah, from on like I have a
I said right
requirement like
already.
on-prem to cloud.
Yeah, I told you no already. We'll be
Uh,
showing those things. I told you when I was talking about database. Yes,
okay, you'll be
we'll be
covering
covering
like
those.
data
Yeah,
migrations, right?
yeah.
Can you show me the topic so that I'll be aware like when it is going on? Just sorry for that.
So when I'm talking about the Azure SQL database, I'll be talking about those things. Okay,
Okay, okay. So how many days it's gonna be taking?
it's going to be around 30 to 35 hours.
Oh, super. Okay. So daily, how many hours you will be taking?
So daily around 1 hour or 1.5 hour it is going to be. We'll try to fix it to 1 hour. If there is anything that we need to discuss more on that day, then it goes to 1.5 hour or something. But mostly 1 hour, 30 days classes. Okay, and then we'll be doing 30
Okay.
sessions.
Okay. So you'll be giving us the recordings also, right? Like whatever you are going to
I
teach.
will not be doing that. The Visualpath guys will be. I am from
No, no, no,
VPath
yeah.
Innovations. I'll be
Whatever,
doing.
like whoever may be. Like I'm just
Yeah,
asking. That's it.
yeah. They will be doing the recording for each and every day, and they will be providing the recording to you guys.
Yeah, because like it will be. We need to have reference, right?
Yeah. I understand that they will be doing, but I will not be providing any material. I am making it very sure, very clear. So we will not be sharing those things, but we'll be sharing the videos. That's all.
No. Okay. Okay. Okay.
Okay, guys, it's already 20 minutes. Any other
So, like,
question?
Ranjit, one and last question, like, what's the timing will be like for the classes?
Timing and all those things, Visual Path team will be discussing with you, team. Okay.
Okay, thank you, Ranjit. Thank you.
Yeah.
Have a nice day.
Any other questions? If not, last one question I can take. If no questions, I'm good
Yeah,
to
hi
close the
Ranjit,
call.
this is Prasad.
Hey, Prasad, please.
Actually, Azure Devops is supportable only for Microsoft technologies or any.
No. Come out of that assumption. No, it's
Yeah,
not
yeah.
like that. Is AWS is